This is our second video looking at example 4, so we're going to look at parts B and C, and then write the formulas below. So in part B it says we want a vector B, and we want it to have a magnitude of 3 going in the same direction as D, and D is still our vector that we had up here. So again, I just want to point out geometrically what's going on. So here was our vector D, and we knew that the magnitude of D was 5. And what we just found out up here was a unit vector that went in the same direction. So that was our unit vector, and that was U, okay? So now what we want is we want a third vector B to have a magnitude of 3 and to go in the same direction as D. Well, we already have this unit vector right here that's going in the same direction as D, and it's 1 unit long. So basically our vector B that we want is simply going to be 3 times the unit vector, right? We want basically 3 of these, right? And that'll give us a vector of magnitude 3 that goes in the same direction as D. So we said that vector B, or I'm sorry, that the unit vector was what? 1/5 of D right up here. So it's going to be 3/5 times 1/5 of D, which simply turns out to be 3/5 of D. And so again, what we'll do is we'll actually get that vector. So we want 3/5 of D, which is negative 4, 3. So that turns out to be negative 12/5, and then 9/5. So again, remember what we're doing is we're simply taking each of these and multiplying it by this to get that new vector. So this is our final answer for this one. All right, then the next one, what we want is vectors, notice that it says vectors B, of magnitude 3 units, which are parallel to D. So when we say that they're parallel, it means that they might go in the same direction or they might go in opposite directions. So if this is my vector D, which has magnitude of 5, we want vectors of magnitude 3, all right? So they could be 3 units going this way, or they could be 3 units going this way. So notice all that does is that changes that K could be both positive and negative. So that means that our vector B this time is basically going to be positive or negative 3 times vector D. So we have to think of this as it could be positive 3D or it could be negative 3D. Whoops. All right, and D again was 1/5. I'm sorry. Sorry, back up. It has to be plus or minus 3U, all right, because this is 3 times the unit vector. This is also 3 times the unit vector, but it's negative. Okay, so now this is going to be 3, and then U, remember, was 1/5 of D, and then this would be negative 3 times U, which is 1/5 of D. So this is going to turn out to be 3/5 D, which we just did just a moment ago up here, so that gave us negative 12/5, 9/5. Or it could be negative 3/5 D, where D is, again, negative 4, 3. And so this time we're going to end up with positive 12/5, negative 9/5. So it could be either of those two solutions. Okay, so coming down here to the generalization then, all right, this one is like part B. So it says if we want a vector B of length K in the same direction as V, then we just have to think about that vector B is going to be K times the unit vector, and the unit vector is this. So it's going to turn out to be K times 1 over the magnitude of vector V times vector V, which simplifies to K over the magnitude of V times vector V. Okay, and notice that this number that's right here is a scalar because the magnitude of V is a number. So this is all just a number. So that's a scalar times a vector. And then if we want it to just be parallel, then that means that basically K can be plus or minus. So that means here our vector B would be plus or minus K over the magnitude of V times vector V. right? And you can go back and double check and see that that's exactly what we did up here in B and C.